Hi, today I'm talking about LeetCode problem 1093, statistics from a large sample. And what this problem asks you to do is write a function that is going to take a list of numbers. I'll talk more about that in a second. And it wants you to compute the minimum, maximum, mean, median, and mode. So you have 5 different statistical values to compute from your input list. Now, this is not an ordinary input list of numbers, but instead it's a kind of frequency count. So they give you this example number 1, with 255 values, and there's a frequency count. And so what this represents is there are 0 number zeros, there's 1 number 1, there's 3 number 2s, 4 number 3s, and so on. So let me show you my illustration of this. Like here, this example list, this one, 4 1s correspond to these 4 1s, 3 2s, 2 3s, 2 4s, and so on. And I just used, small lists because I didn't want to be working with 255 or 256 element lists. But that's how many there are. So it can be a little bit tricky then to compute min, max. Let's see, what was it? Min, max, mean, median, and mode. Given that you have kind of an unnatural format for working with this. It's not the most obvious format. So I see this problem is mostly thumbs down, and I actually found it frustrating myself to work with. For one reason, it's awkward to make test cases when you need to have 255 values in your test case, or 256 values, excuse me. It's awkward to make test cases. It's awkward to reason about more complicated things. You can only kind of reason about small samples like this, like their examples. And then, it's just kind of clumsy to implement these functions, particularly median. The other functions are all really straightforward to implement, but median is awkward to implement because there's this, like the advice they give you. Median means the middle element. Unless you have a list with an even number, then it's the average of the two. So like here, the median is the average of 3 and 4. And you know that because I have an even number, I have 8 elements in this list. So an even number of elements means I've got to average the middle 2. If I had an odd number of elements, so like here I have 11 elements, then I just pick the number in the middle so that I have 5 elements on the left-hand side, 0 through 4, and I have 5 elements on the right-hand side, and then 5 is the exact median. So it's just kind of like a special case, and that special case is more awkward because instead of dealing with a list like this, you're dealing with this frequency count thing. So it's awkward to implement, it's hard to test and reason with, and I think that's probably why there's a lot of downvotes. Well, I didn't want to give feedback. I think that's probably why there's a lot of downvotes. And then also I guess it's just kind of boring to implement 5 easy functions. So like this is a medium difficulty problem, but really, these are just 5 easy things to implement. So how I did this, my sample stats function, which is the function they require me to write to solve the problem, is just going to return calling 5 individual helper functions that fulfill the minimum, maximum, mean, median, and mode. And the other thing I'm doing here on line 60, I'm going to compute the total, meaning how many numbers total are in my frequency count list. And that's just the sum of these numbers. So you can see that here. How many numbers are here? Well, it's 8. It's 1 plus 3 plus 4, or the sum. And the reason why I compute the total in line 60 is because the total is useful for both the median. We need to know if there's an even number of numbers or an odd number of numbers, so we know whether to average 2 in the middle or not. And it's also used to calculate the mean. So the mean is just, well, it's another word for the geometric average. Geometric average? I think that's right. Geometric average. let me see if I've remembered that term correctly. Arithmetic mean, excuse me. That's what we mean. Not arithmetic mean. The geometric mean is something else. Arithmetic mean. Anyway, it's what people commonly refer to as average. Yeah. Anyway, let's look at how we do the minimum. Oh, another reason why I think I dislike this is because it kind of leads, at least the code I wrote for this was very ugly. It's very, very unsatisfying to write. So the minimum, all I have to do is find an index where there's a value at that index that's greater than 0. And then I have to find the smallest such index. So in my code, I guess I'm looping through all of the values. As I'm reading this aloud, I realize I don't have to. I just have to find the first index where the value is 0. So let me actually replace this dumb logic with, let's just say we, for I and num in enumerate count, if num is greater than 0, so if the value in the list is greater than 0, we're going to return I, meaning I'm just going to step through. Is this greater than 0? No, that is 0. Is this greater than 0? Yes. So I'm going to return I, which is 1. And that, that may be confusing because the value here is 1. That's another reason why I dislike this, is because you're constantly, it's like the puzzle where, someone writes something like this and asks you to point to blue. You're constantly dealing with numbers that represent frequencies of values. And that can just be kind of unintuitive to think about, or it can kind of lead you to make mistakes, which is another reason I dislike this, because it just kind of encourages you to be clumsy. Yeah, let's see if that hasn't broken us. Good, we can still find the minimum. And I think that's a bit smarter of a way to do it. And then maximum is basically the same thing. I wrote it stupidly, the same stupid way, which I've now realized I can just iterate backwards over the list and find the first value that is greater than 0. So this notation, if you're not familiar with it, or notation or way of invoking the range, just says start at the size, and then we're going to go smaller and smaller. This is the start value, this is the end value, and this is the increment. So start at the length of the list, -1. So start at the last element of the list and keep going until you're at -1, decrement by 1 every time. And what I'm going to do is say, if count sub I is greater than 0, we will return I. I hope that'll work. Yep, that still works. So that's good. So this is just saying, okay, start at the other end. If this is greater than 0, then return the index that you're currently at. And we're guaranteed in the constraints that there will be at least one number, which is why I don't have to do anything if I haven't found something. Okay, so we've got minimum, we've got maximum, median. This is where it gets complex. This is the difficult one to write. Median, like the key here is that half of the values you've found are lower, so you're ready to determine if you found the median or not. And I tried to write this a couple different ways, so I have at least one variable here that's completely unnecessary, accumulated. So let me just, like these flags, half is because we're looking to find half our values on the left side, half the values on the right side. Numbers, this is the numbers I've counted so far. And previous, this is because when we find the halfway point, we want to go one past it. So in this example, we have 8 numbers. So we want to look for 8 divided by 2 is 4. That's our halfway point. We want to get the index at the halfway point and the index 1 before it. So yeah, that's why I'm tracking something called previous here. I'm going to keep going until I find the value at our halfway point, and then I'm going to average it with the previous value. That's the logic behind prev. So I'm going to enumerate over the frequency count. If num is 0, then just keep going. That means there are no values of size I. Line 25, if next num, this is a flag telling me I've found the halfway point and I need to average. So if this flag has been set, then just go ahead and return I plus prev over 2. Return the average of my two numbers. And you'll see where next num gets set, why it makes sense that I can do this. The next if statement, and again, this is what I mean by kind of terrible code, or like I felt very bad writing this, like just a series of if statements. But I could think of more elegant solutions for this, but they would all be significantly slower, like pulling the count table or the count table out into a list and then finding a median a more traditional way would be much slower. So this feels clumsy. I'm sure there probably is a better way to do it, but it made me dislike this problem. So here what I'm doing, if the number or num, the number of values of size I plus the numbers I've accumulated so far, or I've counted so far, is greater than half, then I can just return I. And so that may or may not be perfectly obvious to you. But like basically the logic is, imagine I have a list like this, 5. Like this is my expanded list, not the frequency count. What this is saying is, okay, let's see, how many values do I have here? 4, 6. So my halfway point is 3. 0, 1, 2, 3. Whoops, I've done something dumb. Yeah, okay. My halfway point is 3, and I want to average this value. What I'm saying is, if the number of 2's I have plus the number of things I've already looked at is greater than my halfway point, then I know that the halfway point is going to occur somewhere within my list of 2's. And then the average would be summing these two and dividing them by 2. In other words, the average would be whatever is within this list. So this is saying num plus numbers being the number of numbers that I've counted so far, plus the number of numbers of size I. If it's greater than half, that means the median is going to fall somewhere within this range, the range of 2's. And I don't have to worry about averaging it, whether or not the total is positive, is even or odd. The other possibility is that num plus numbers is, well, there are two other possibilities. One possibility is that it's exactly equal to half, in which case then I set the next number flag to be true. And I set my previous value to be I, meaning we've hit exactly the halfway point, so the next number that we encounter will need to sum an average. Yeah, and the other possibility is that we just aren't at the halfway point yet, in which case we'll just accumulate or increase our numbers value by num. So that's the median function. It's a mouthful to say and think about. And I'm pretty unsatisfied by how it looks and reads, because it feels very inelegant with like 5 if statements. More complicated than it needs to be, I'm sure. The next function is just the mean function. And so this one, again, is pretty straightforward. It makes use of the total I talked about before. But I'm just going to sum up the value. I'm going to, like the sum of all these values divided by the number of numbers there are. So if we can take the sum of this kind of expanded list and divide it by the number of numbers that there are, meaning 4 plus 3 plus 2 plus 2, then we get the average. So we already know the number of numbers that there are. That's given to us in total. And we get the sum just by iterating over our list and increasing the sum value by the product of the index and the value stored at that index. So in other words, this would be 0 times 0, like our sum, or whatever I called it, is 0. This is 4 times 1, so it's plus 4. This is 3 times 2, so it's plus 6. This is 2 times 3, so that's plus 6. This is 2 times 4, so that's plus 8. And now we know 1, the number of numbers, and 2, the sum of all the numbers. And returning the sum over the total of numbers gives us the mean. And then mode, as you may recall, is just a number that occurs most frequently. And to find that, I just converted my frequency count into a list of pairs or tuples, where the first element in the tuple is the index, and the second element in the tuple is the value in the index. And then I just sorted by the value and returned the first number, or the first index that corresponds to the greatest value. So you can see the sort here is by their frequency count, and it's reversed. By default, Python sort will be in ascending order. When it's reversed, it's in descending order. And so then I can just return the first, meaning the greatest value, and the index that corresponds to the greatest count. That's what nums vals 0, 0 means. Yeah, and so that is the entire logic of it. I guess for test cases, as I mentioned, it's difficult to make test cases for this. I used their 2 examples, and then I also used just random numbers. So I just used the Python interactive shell here to make some random numbers. So I have one with a lot of zeros in it. I tried creating random, or not random numbers, but just extremely large numbers. So as large as they would allow, just to make sure that I wasn't going to time out in something or encounter an error there. I tried a test case where, like, oh, what if all the values are 0? Does that cause any problems for me? 0 is kind of special, and it's the test case of what if there's just one number? Like, do I handle the mean and do I handle the min and the max correctly? That kind of thing. Another one, what if there's just one number? I have, one here. So I tested also what if I have a even number for the median and an odd number for the median. It's passing my test cases. I submitted this a little while ago. Let's see. I guess I submitted it 18 minutes ago, 11 minutes ago. I can't do math. I submitted it 19 minutes ago. Substantially slower. Though, oddly, when I submitted it last time, I thought I had a much higher percentile. But clearly it's pretty much the same as I had last time. 48 milliseconds instead of 44. So how I would improve this if I were kind of insisting on improving this, I think min-max is obviously very fast. Median, I'd like to, well, I'd like to put this under a profiler and see where the time is getting spent. I assume it has to be, median is definitely the most complex. Mode may take more time because mode is not only constructing a tuple for each value, it's also sorting them. But that said, like if we were to talk about the big O runtimes of these, maybe it's valuable. You know, this is O of 1, basically. This is constant, meaning at worst it has to run 256 operations. I guess the in our case is going to be, like the thing that varies is the sum of the values in our array. Our input is always an array of 255, but these numbers inside of the array can change and can get much, much bigger. So I suppose that is our in, which is varying. And the min function is going to be constant with respect to that in. Same with the max function. The median function, what is that going to be? I guess the median function is going to be O of n, because the more numbers there are, the longer we need to run through this. Mean is also going to be constant, I believe. We have to do 255 multiplications. And same for mode. We have to create 255 tuples and then sort them. But like these functions don't get slower the bigger these values are. So I would say, I guess, that median is probably where most of the runtime is going from. Is there anything we could do to speed up median? I don't know. I'll give it just 1 minute to see if I think of anything. Well, no, I mean, it doesn't even seem that, I don't know, I'm sure there is something we could do to speed it up, but it doesn't seem that slow to me. And it is running in 48 milliseconds, so I wonder if I just run it again, if I get something very different. Yeah, okay, that's what I thought. So when I just ran the exact same thing, a second time I got 44 milliseconds runtime, but my percentile score went from 15 percentile to 50 percentile. So that must mean I'm in kind of like the, yeah, the most common band. So just like tiny fluctuations can move me up or down by quite a bit. And I would bet that actually this is a result of random fluctuation as well. So it looks like there is a much smarter solution, but I'm not going to find it here. Anyway, if you enjoyed this video, let me know by clicking the like button. If you want to see more LeetCode problems solved and kind of walked through and explained like this, then you may want to subscribe. Yeah, thanks for your time. Bye-bye.